Alright, so I think I'm recording. Let's take a look at problems 5, 6, and 7. They all have the same directions. They give us a graph. Um, they ask us, and remember, a graph is just a collection of ordered pairs, infinitely many points that they've plotted. So it's a relation. Any set of ordered pairs is a relation. So they want me to determine the domain and the range of this relation, and also to determine if this relation um, it achieves the title of function. If it, like I say, I think of it most of the time as getting a promotion. All right, so when I am determining the domain, I'm interested in only the x-coordinates of every point on the graph. And the points on the graph provide you two pieces of information at the same time. It gives you information about x, but it also gives you information about y. So the difficulty is separating these two pieces of information. If I use a straight edge, a ruler here to help me, when I'm going to write my answers in interval notation. In interval notation, I always have a smaller value, comma, a larger value. When I come into the graph where the small x's lie from the left, haven't touched the graph yet, and the first time I come up and I touch the graph is at this hollow point, and the coordinates at this point are negative 3 comma 1. I'm only interested right now in the x-coordinate, and since that's not a solid point, it's a hollow point, that's indicating that this negative 3 comma 1 is not a point on my graph. So negative 3 is not related to 1 as far as this graph is concerned. So negative 3 is not in my domain. Alright. Now, as I continue moving through the right, passing through all these points, I don't have any other holes in the graph. I don't have any jumps in the graph. And I come to the right side here where this endpoint, and I'm interested in the x-coordinate of that point. Well, that point has coordinates 7 comma negative 4. Now, this point is different than the other point. It being solid is indicating that our graph is passing through that point, that 7 is in the domain, and in fact 7 is related to negative 4. So when I write my right endpoint, I have to include a bracket to indicate that is a member of the domain. So there's my domain from negative 3 to positive 7 in interval notation. Now for the range, again, I want smaller value, comma, a larger value. The range is the set of y values. So when you're plotting points, y controls up and down from the origin. So I'm going to come at the graph from below, and when I come at it from below, the first point that I hit in the graph is this point right here. Looks to me to be the vertex of this portion of a parabola. So the coordinates at that point are 3 comma negative 8. But this time I'm interested in the y-coordinate of negative 8. And since it's not a hollow point like the previous one here, the first point that we hit in the domain, it's a solid point, I have a bracket. Now, if you're listing the members in a set, once you're in, you're in. You don't have to list members twice. So when I start to go up here, I can follow either one of these paths going up because all of these y-coordinates here are just repeated as y-coordinates over here. When I get to this negative 4, there's no y-coordinates on the right half that are still on the graph, but over here to the left, I have a point that right here, negative 1 comma negative 4. So this point has the same y-coordinate as that point. Since I'm listing my y values, negative 4 is in my interval, and I just continue moving up. And so I'm just moving along these points of the graph. So if you focus your attention on the left side here, then you can just trace that all the way up until you hit this hollow point, which has a y-coordinate of 1. But remember, this point is not on the graph, so that 1 I exclude, and I exclude it with an open parenthesis. So there's my domain and range for this function. Now, to determine whether this is a function or not, does it pass the vertical line test? If it can I find a vertical line that intersects my graph in more than one place? And I cannot. It passes. So therefore, yes, this is a function. Let's move on to problem number 6. It's going to be similar in the idea. If we're finding the domain, let's come at it from the left. Okay, these are the smaller x values. And I hit my graph in 2 places at the same time. Each of these points has an x coordinate of -3. This is -3, 4, and this is -3, 8, -8. So the negative, once you're in, I don't list it twice. -3 is a point on the graph. -3 is a point in my domain. As I move to the right, I don't see any holes or any jumps in the graph. I get all the way here to the right, and all of a sudden there's a last point. If I move too far to the right, I don't have any points on the graph. So I want the coordinates of this point, and more specifically, I'm interested in the x coordinate. And since that's not a hollow point, this 3, I'm going to include that. And this is my final answer for the domain. Don't get confused. This was just the coordinates of this point. It wasn't part of my answer in the domain. It's kind of close together. All right, for the range, I want to look at this graph, but I want to only consider the y coordinates. The range is a set of y values. When I come at it from below, again, this point is the first point I hit. But however, this time, I'm only interested in the y coordinates. It's a solid point, so the point is in my range, and I want the y coordinate of -8. And then as I go up through the graph, I have more than one y value that's in there, but once you're in, you're in. And I don't have any holes or jumps in the graph. It's all of these y values are in. And then as I'm moving up through the graph, I hit this final point here where there's no point above that point that's on the graph. So this 4 is an endpoint. Since it's solid and not hollow, I include that y coordinate. And so there's the range for this relation, the domain and the range for this relation. This is a set of x values. This is a set of y values. Now, is this relation a function? Does it pass the vertical line test? Well, I can find a vertical line that intersects my graph in more than one place. So it fails. If it fails the vertical line test, it fails to be a function. This relation is not a function. All right, let's take a look at number 7. We're familiar with this. This is the quadratic function. So when I get down here, I'm going to pretty much argue, well, yeah, this is a graph that I have memorized from a library of functions that I know. It passes the vertical line test. It's a function. Now the domain, when I come in from the left, this time I hit an arrow. And that arrow, all of these points are giving us 2 pieces of information at once. Information about x and information about y. This arrow is telling me that x is going out to the left here, -infinity, and is going down to -infinity. The x on the right, the y values going down, the x values going to the right, the x's are going to +infinity, going down is -infinity. Okay, so for the domain, I'm only interested in left and right. As I come in and I hit that arrow, I know I'm coming in from -infinity. I also know that you never put a square bracket around positive or -infinity. As I move through the graph, I don't have any jumps or any holes in the graph. And I get over here to the right side of the graph, when I hit this arrow, I know that's 2 pieces of information about y, but I'm not interested in that. Only information about x. As you're going down, you're also going to the right, and to the right means that you're heading towards +infinity. So my domain is a set of all real numbers. Written in interval notation, we have it from -infinity to +infinity with open parentheses at each end. Now for the range, here I'm going to erase. No, we'll keep that. I'm afraid that it's getting cluttered, but when I come at the graph from below, because remember, in writing interval notation, we want a smaller number comma larger number. If I come at it from above, those are where the larger numbers live. I need to come at it for the first number in my interval. It needs to be the smaller values. Well, the first thing I hit again is the arrows, and the arrows give me two pieces of information. The information about the y values, the up and down, is that when I'm coming at it from below and I hit that arrow, I know that below it's going off to negative infinity. And all I need to do is trace one side of this, because all of these points have the same y coordinates. Over here they have different x coordinates, but they have the same y coordinate, all the way until I get to the vertex. The vertex has coordinates 0, 4. 0 is an x. I'm not interested in that, but this 4, I am interested in that 4. There's no point on the graph that's above that, so I know that this 4, and since that's a solid point, I have a bracket here. Alright, so there's my answer for problem 5, 6, and 7, and I hope that helps, and I will talk to you later.